Hi everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. So today we are going to see another method to find the optimal solution, and this method is modified distribution method, also known as MODI method. So in the first lecture of transportation we have considered this problem, and after solving this problem we have obtained a basic feasible solution. So this is the basic feasible solution we got by Vogel's approximation method. Now we will like to see how we can find the optimal solution by using the modified distribution optimality test. So let us start. So first of all, we need to understand that in this particular cell, the allocated cell is known as basic cell and the empty cell or non-allocated cells are known as non-basic cells. So first of all, we need to calculate, or we need to first find out the values of new variables for modified distribution method. So let the variables be u1, u2, u3, v1, v2, v3 and v4. So these are the variables we have taken, and we need to find out the values of these variables, and we will find out these values with the help of these 2 points. So first of all, we need to understand that for allocated cell, or what we call it basic cell, the value of Cij is equal to ui plus vj. That means if I am talking about the cell 1, this is allocated cell. So for this particular cell, the value of Cij, that means C11 unit transportation cost, must be equal to the summation of u1 plus v1. So let us say for cell C11 we will have, or cell 1 we have C11 is equals to u1 plus v1. So out of these 3 variables, if we know any two variables, we can find out the third variable. So in order to find out the values of u's and v's, what we'll do is we will take any one variable as 0 and find out the corresponding values of the other variables. So generally what we do is we will take u1 as 0 and find out the respective values of other variables. So in this cell C11 is 2, this is unit transportation cost 2, this is unit transportation cost, and the value of u1 we have known it is 0. Similarly the value of v1 is unknown. So here from this we can find that v1 is equals to 2. Similarly we need to find the other variables with the help of allocated cells. So here we know that 0 plus 2 is equal to 2, and let us calculate the other values. So this is also a basic cell. 0 plus what equals to 3, that means 0 plus 3 equal to 3. Now once we have find out this value v1, we can find out the value of u3, that means 2 plus what equal to 5. We know that 2 plus 3 equals to 5. Similarly when we know u3, then u3 plus what equals to 15. So we know that u3 plus 12 will be equal to 15. So this will be 12. Now similarly u plus what equals to 9. Then we know that 3 plus 6 equals to 9. And once this is known, 6 plus what equals to 1, then 6 plus minus 5 equal to 1. Here we can see that all the variables u and v can take any value that is positive or negative. Here is no restriction on the values of u's and v's. That means u can take any positive or negative value. Similarly, v also can take any positive or negative value. Now, once we have find out all the values of u's and v's, what we need to calculate is, we need to calculate this value for the non-allocated cell, or we call it non-basic cell. So there are 6 non-basic cells, and we need to find out the values of Cij minus of ui plus vj. Suppose if we consider the cell 1, 3. So for cell 1, 3, we will have the value as Cij. Cij is 11. So this will be C13 minus of U1 plus V3. C13 minus of U1 plus V3. So the value of C13 is 11 minus U1 is 0 plus V3 is 12. So here we are getting the value as minus 1. So we will put the value of minus 1 in this particular cell. So this will be minus 1. Similarly, we will calculate the values at all the non-basic cell. So for this particular cell 1, 4, then 7 minus of 0 plus 4, that means 7 minus 4, this will be 6. 7 minus of 0 plus 6, this will be 7 minus 6 is 1. So we have written plus 1. Similarly, for this particular cell, 1 minus of 2 minus 5. 2 minus 5 is minus 3, and minus of minus 3 is plus 3. 1 plus 3 is plus 4. So this will be plus 4. Here 0 minus of 3 minus 5, that means minus 2. 0 minus of minus 2 is plus 2. So this will be plus 2. Similarly, for this particular cell, 6 minus of 12 minus 5. 12 minus 5 is plus 7. 6 minus 7 is minus 1. And similarly here 8 minus of 3 plus 3, that means 8 minus 6 is plus 2. So here we have calculated the values at non-basic cells, and what this value suggests that if I allocate 1 unit in this particular cell, the overall transportation cost will decrease by 1. Similarly, if I allocate 1 unit in this particular cell, the overall transportation cost will increase by 1. Similarly, here if I allocate 1 unit, the total transportation cost will increase by 4. Similarly, here if I allocate 1 unit, the overall transportation cost will increase by 2. Similarly, if I put here 1 unit, overall transportation cost will decrease by 1. And if I put here an allocation, the overall transportation cost will increase by 12. So as we know from the previous basic feasible solution that the value of Z for this particular solution is 10200 rupees, because these are all hundreds, transportation cost is in hundreds of rupees. So now what we will do is, we can see that there are 2 cells here, cell 1, 3 and cell 2, 3, and these 2 cells are showing negative values. That means if I allocate any unit here, it will decrease the transportation cost, and because the negative value of both the cells are same, I can choose any one of them to allocate. So let us see. If I take the value, suppose if I select this particular cell, and what I'll do is I will allocate plus theta unit here. That means previously it has m minus n, m plus n minus 1 number of allocations, that is 6 allocations, and after allocating here we have 7 allocations. That means we have greater than m plus n minus 1 number of allocations, and this suggests that now this matrix will certainly have a loop. So now let us find out the loop. If I start from here, it is very clear that this is the loop it is forming, moving from here, here, here. Now after we find out the loop, we have to maintain the supply and demand. In order to do so, what I'll do is, if I have added or allocated theta units here, I have to withdraw theta from here, minus theta. If I have withdrawn theta from here, I need to add theta here, so this will be plus theta. If I have added theta here, I have to withdraw theta from here. So plus theta, minus theta, plus theta, minus theta. Now let us understand what is theta. So theta is the maximum amount that we can allocate at this particular location. So let us find out what is the value of theta that we will be able to allocate at this particular cell. So we can see that here there is no restriction on the value of theta in this particular cell. That means theta can be indefinitely increased. Similarly, when we see here 1 plus theta, there is no restriction on the value of theta, and here also we can increase the value of theta indefinitely. But in these two cells, this is 1 minus theta and this is 3 minus theta. Here the value of theta is restricted. In this particular cell, the value of theta is restricted to 1, because we can only put the value of theta as 1, as 1 minus 1 will become 0, and if I increase beyond 1, this will become negative, which will violate our non-negativity restrictions as per the transportation problem. So the maximum value of theta we can put here is 1, and when we see here, this is 3 minus theta, and the maximum value of theta we can put here is 3, so that if we go beyond 3, this will become negative, and this will violate our non-negativity constraint. So among these two, here the maximum value of theta can be 1, here the maximum value of theta can be 3. So among these two, we will select the minimum value, that means theta is equals to 1. So here we will select that the value of theta is equals to 1. So we will put the value of theta is equals to 1, so that we will find a new basic feasible solution. So let us do it here. Plus theta, that means theta is equals to 1, so this will become 1. This will be 1 minus theta, 1 minus 1 will be 0, so there will be no allocation here. 1 plus theta, that means 1 plus 1 is 2, so this will become 2. And this is 3 minus theta, that means 3 minus 1 is equals to 2, so this will become 2, and the remaining allocation will remain as it is, 1, 5 and 6. So this is our new basic feasible solution, or improved solution, what we call it, and we need to find out the value of z for this particular solution. So the value of z, when we calculate, we will get the value as 15 plus 30 45 plus 30 75 plus 20 95 plus this 10100 rupees. So this is the value of theta, value of z we have obtained by this solution, which is lesser than the previous value of z. Now let us check again if this particular basic feasible solution is optimal or not. Again we will use the same modified distribution method. That means again we will have certain sets of variables u1, u2, u3, v1, v2, v3 and v4. Now we will take any arbitrary value as 0, and for allocated cell we will take Cij is equals to ui plus vj. So for allocated cell Cij is equals to ui plus vj. So 0 is equals to 2 is equals to u plus what? So this will become 2. Similarly here 0 plus what is equals to 3. This will be 3. And once we find out v1, we can find out u3. That means 2 plus what is equals to 5. So this will be 3. Similarly, once we have calculated u3, we can calculate v3. 3 plus what equal to 15. So we know that 3 plus 12 is equals to 15. Similarly, when we have 12 plus what is equals to 6. So 12 minus 6 is equals to 6. So this will become minus 6. And this is 3 plus what is equals to 9. Then we know that 3 plus 6 is equals to 9. So now with the help of this allocated cell, we have calculated all the values of v's and u's. Now what we need to do is, for non-allocated cell, we need to calculate the values of Cij minus of ui plus vj. That means for this particular cell, this is 11 minus 0 plus 12. So 11 minus 0 plus 12, that means 11 minus 12, which is equal to minus 1. Similarly for this cell, 7 minus 0 plus 6. So 7 minus 6 is plus 1. For this cell, 1 minus of 2 minus 6. 2 minus 6 is minus 4. So 1 minus of minus 4 is plus 4. 1 plus 4 is plus 5. And here we have 0 minus 3 minus 6. That is minus 3. Minus of minus 3 is plus 3. So this will be plus 3. And this will be 1 minus of 6 minus 6 is 0. So this will be plus 1. And this 8 minus 3 plus 3. That means 8 minus 6 is plus 2. So again we have calculated the values at non-allocated cell as Cj minus of ui plus vj, and we found that there is one cell 1 3, cell number 1 3, which is showing the negative value, and this shows that if I allocate 1 unit here, the overall transportation cost will decrease by 1 unit. So what we are going to do is, we are going to allocate here. So let us allocate the value theta. Theta is the maximum possible allocation that can be made in this particular cell. So now also we can see that previously there are 6 allocations, which is equal to m plus n minus 1 number of allocations, and by increasing this allocation it will exceed m plus n minus 1 number of allocation, and now this will definitely form a loop. Now let us see what is the loop it is forming here. So it can be clearly seen that this is the loop it is forming. So this is the loop, and to maintain the supply and demand, if this is theta, then this has to be minus theta. This is minus theta. If this is minus theta, this has to be plus theta, and this is plus theta, this has to be minus theta. Now let us see what will be the value of theta. So we can see that where we have plus theta, we do not have any restriction on the value we can allocate, but in case of minus theta, we need to see that this is 1 minus theta and this is 2 minus theta. So here the value of theta is limited to 1. Theta can be only 1, and in this particular cell theta can be only 2, because 2 minus 2 will be 0. So among these two, the minimum value is here for theta is equal to 1. So what we are going to take is the value of theta is equals to 1. Now let us allocate the value here, and we will get our improved solution. So by allocating here, we will have one allocation in this particular cell. So this will be 1, and this is minus theta. So 2 minus 1 will be 1. The new allocation in this particular cell is 1. Similarly, in this particular cell, 6 plus theta, that means 6 plus 1 is 7. So this will become 7. And this will be 1 minus 1. That means previously it has one allocation, and by removing it, there will be no more allocation available. And the remaining allocations 5, 1 and 2 will remain as it is. 5, 1 and 2. This will remain as it is. Now this is our improved solution, and we will again calculate the value of z for this. So let us calculate the value of z here. Z will be, this will be 15 plus 15, 30, 30 plus 35, 65, 65 plus this is 76, 76 plus 6, 82 plus 1800. So this will be 10000 rupees, and this shows that this value of z is lesser than the previous value of z. Hence our solution is better than the previous solution. Now this feasible, so this is the feasible solution, new feasible solution, and again we need to check whether this solution is optimal or not. So again we have to use modified distribution method, and again we will have a set of variables u1, u2, u3, v1, v2, v3, v4, and we will put any one of the variable as 0. So I have chosen variable u1 as 0. Now for the basic cell, we have Cij minus of ui plus vj. So let us see. This is not the basic cell, this is non-basic cell because there is no allocation. This one is the basic cell. So 0 plus what is equals to 3. So 0 plus 3 is equals to 3. Similarly, 0 plus what is equals to 11. So 0 plus 11 is equals to 11. And from here 11 plus what is equals to 6. So 11 minus 5 will be equal to 6. And 11 plus what equal to 15. So 11 plus 4 is equal to 15. And 4 plus what equal to 5. 4 plus 1 equal to 5. Similarly, 4 plus what equal to 9. So 4 plus 5 equal to 9. Now again we have calculated the values of u's and v's with the help of this. For allocated cell, Cij is equals to ui plus vj. Now we need to calculate the values at non-allocated cell, which is Cij minus of ui plus vj. So we will see for the first cell Cij 2 minus of 0 plus 1, that means 2 minus 1 is plus 1. So this will be plus 1. Similarly here 7 minus of 0 plus 5, that means 7 minus 5 is plus 2. Similarly here 1 minus 5, 1 minus 5 is minus 4, and minus of minus 4 is plus 4. So 1 plus 4 is plus 5. And this is 0, 0 minus of 3 minus 5, 3 minus 5 is minus 2, minus of minus 2 is plus 2. Here 1 minus of 5 minus 5, 5 minus 5 is 0, so this will be plus 1. And 8 minus 4 plus 3, that means 8 minus 7 is plus 1. Now here in this table we can see that all the non-basic cells are having the values greater than 0. That means if we choose any of these cells and allocate there, the overall transportation cost is going to increase only. So this is our best solution, and we will not able to obtain a better solution than this. So this will be our optimal solution, and the value of z here is the minimum value, or we can say that this value is z minimum, and this is the optimal value we can obtain here. So this is the optimal value we can obtain here. So this is our final solution, and giving the optimum value of Z as 10,000 rupees, and the allocation is for cell 1 2 we have 5 units, cell 1 3 we have 1 unit, cell 2 3 we have 1 unit, cell 3 1 we have 7 unit, cell 3 3 we have 1 unit, cell 3 4 we have 2 units. So these are the final allocations to give us the optimal solution. So in the next lecture we are going to see another problem to solve the transportation model. Till then, have a nice day. Thank you.